Hey Dr. Zhang, so this is our third video project and I'm gonna verify buoyancy force. So to do that, I've got a rock, I've got a thing of water, and I have a fish scale that you'll see later. So first thing, we need to find the volume of this rock. And I can't really do length times width times height on it. So what I'm gonna do is I'm gonna measure the height of the water in this bucket, put the rock in the water, and then measure the height afterwards to get the volume. So if I do this height right here, bring it out and I measure it, that's going to be about 4.75 inches. I put the rock in there, measure it with the other side, that's going to be 5 7/16 inches. And so with that, I can do the area of the circle times the height, and I get the volume of the rock. All right, so now to do the buoyancy force, we need to find the weight of this rock and the tension that this rock puts on the thing whenever it's in the water. So this weight right here, we're gonna look at it. The weight is about, I want to say 1.4 kilograms. All right, so 1.4 kilograms. I'm going to submerge the rock all the way so we can have the full volume submerged. Rock is submerged all the way. And now the scale reads about, I'd say, 0.65 kilograms. So that's a pretty big drop in the tension. So now let's go look at the math for it. Alright, so let's look at the math of this buoyancy force problem. Here's our diagram. You can see the buoyancy force and the tension are pushing the rock up and the weight is pushing it down. So we'll get to that in a second. So our weight is going to be the weight that we found times the gravity, and the tension is going to be the weight times the gravity. Those are there in newtons. And so to find our volume submerged, we have to do the change in height of the water multiplied by the area of the circle. So the diameter, I took the average of the diameters of the two parts because the bucket was not the same diameter going all the way up. I found the area of the circle multiplied times the height, and that's our volume submerged. And then the buoyancy force is gamma times volume submerged to get the buoyancy force. And all of this is supposed to equal 0 because the rock is not moving. And when we added it up, it's not exactly 0, and that can be because I did not read the scale correctly. It was not a digital scale, so I didn't know exactly. And the rock was porous, so water may have gotten inside the rock and made it heavier than it should have been underwater. And maybe a few other things went wrong as well, but otherwise, that's what it was supposed to be. So, this is it. Thank you, Dr. Zhang. Had a good time doing this. I'll see you next time.